Hi guys, Mr. Bennett here. Just going to be looking at exercise 2B today, where we're looking at optimal solutions. Now, again, this is a bit of revision from year 11. And generally the way these things work is you get given an equation with some information in it, and then you have to use another equation which you want to maximise or minimise. So in this particular case, we'll look at example number 2. So Annie has 20 metres of fencing to form 3 sides of a regular chicken pen. So you can see the example of the brick wall over here, and we've labelled those already for x and y for you. So if y is an x as shown in the area, show that the area of the pen is given by this. So to do that, what we'll need to do in part A is we'll need to find that connection between x and y. Now we know that the perimeter of this thing over here is equal to what? Well, we know this side over here is x as well. So the perimeter of the shape, which is equal to 20, is actually equal to 2 lots of x plus y. Alright, so we always use something that's given to us to find one of these variables in terms of the other one, and quite often we would say, therefore, if that's the case, y has to be equal to 20 take 2x. Sometimes we even ask you to show that. But if we're looking at the area of this shape, well, we know the area of this shape is simply x times by y. So that's going to be equal to x times by, now we know y is equal to 20 take 2x. So therefore, we could say that's equal to 20x take 2x squared. Right, so I've actually shown that even the next stage on. So that's how we get that. Now the reason why I give you that is so if you couldn't do that connection over here, where we see that the y value is equal to this, if you couldn't find that, and I expect you should be able to find that, then you can go on to the next part of the question. So use technology to help sketch that. So if we go to our calculator, we can put it into our calculator exactly as we see there. Now I need to clear all those things, of course. So I need to put into my calculator x bracket 20 take 2x. Now I could have also written it the way I'd also had it there. And then obviously if I graph that, I'm not going to see that. I've got my x value one, so I need to go and turn my scatter plot off. So go to there, turn it off, and I have to think about a possible scale. Okay, so what would be a possible window? What would be the maximum x could be? Well, if it's got a perimeter of 20, it can't be any bigger than 20. Let's go 20 as a maximum. So if that was, let's say, an average like 10, and then 10 and 5, so that's going to be about 500, isn't it? So let's make our y value min maybe -2, and let's make that about 1,000. That definitely cover it if we made it 1,000. So if I graph that now, you can see obviously it's going to a maximum there. Obviously I can make my y value a little bit smaller. Let's make that say 500 and graph that, and you get a better representation. It's certainly not even going to be that. All I'm looking for is a sketch. Obviously 500 is way too big. If I come down to make that maybe 100 and graph that. Right, and then I'm looking for this value. So go to my G-Calc, looking for my max value number 4. Go to the left hand side of that. Enter. Go to my right hand side of that. Don't enter, and then I don't want to make a guess. I want to find that value. So it's roughly 4.99, which we know is 5. 5 and 50 is the answer. Alright, so if I go back to my thing over here, it says use technology to find a sketch. Alright, so I should just sketch it. Okay, so this is my area. Alright, remember I made that 100. So it's going to go like that. Right, We know that value there is 550. That's the key thing over here. All right, so we'd make that say 10. All right, over there. Okay, so I've done my sketch. I know what my max value over here is, and then it's asking me to find the value of x which maximises the area of the enclosure. Right, so and then does it say sketch the optimal solution? So part C is we just have to read that off. X is going to be 5. Right, so if that's going to be the case, then we know that y is equal to 20, take 2 lots of x. So that's going to be equal to 20 take 10, which is 10. So what it's asking you to do is to sketch that. We've got our brick wall over here. And so our optimal solution is going to be a 10 metre thing by a 5 metre thing. Alright? So that's what our optimal solution is. Answer the bits. Using technology is a key. Alright? Let's have a quick look at number 5. Manufacturer has a 1 litre capacity for the tin. So again, I'm thinking over here, this is the key bit of information I'm going to use to find H in terms of R. Alright, so the first thing is explain why the height is given by that. Well, this is a tin, okay? So this is a tin where the cost of material to be monitored. Okay, so if we were going to do that, the surface area of the tin has got 2 circles plus a square thing over here, right, which is made by unwrapping that. So if I'm looking at my volume, first of all, I'm going to use my volume formula. So volume is equal to 1 litre, which is equal to 1,000 cubic centimetres. All right. Now the volume of this shape here, because it's a prism, is the area of the base, which is simply pi r squared times by h. So therefore, all I have to do is basically bring this thing down the bottom. So therefore, h is equal to 1,000 divided by pi r squared. Now they'll generally ask you to show that, so you can make sure that they can make sure that you know that. So if you couldn't see that bit, then you can use it for the rest of the question. So I've got that relationship. It says show that the total surface area of that's given by this. So part B. So what we have to do is think about the surface area of my shape. So my surface area is in fact equal to 2 circles plus a rectangle. Now if you think about opening up that shape, it's got a height of h, and then that's going to be the circumference of the circle, 2 pi r. So that's going to be 2 lots of pi r squared plus 2 pi r times by h. Now we know that h is equal to what? H is equal to 1,000 over pi r squared. Now keep in mind, what you should be always looking at is we want to prove this thing to be. But I'm not going to worry about doing that. I'm just going to do what I know is the right thing and just plug it in and then try and simplify it. So I can cancel out that with the r squared. I can cancel out the pi with that pi there. And so that's going to leave me with 2 pi r squared plus 2 times by 1,000, which is 2,000 over r. Now if I go and look at that, yes, that's exactly what I had there. Alright, so that's what I have to prove. Alright, then part C says use technology to find a sketch of area versus that. So I'll go to my calculator. Right, go to thing, let's clear that. So what have I got? I've got 2 times by pi times by r. We'll just use x, and that's going to be squared, plus 2,000 divided by x. Okay, and we're going to graph that. We always graph it to see if we're going to get something which, you know, fits on there. I'm looking to try and find a minimum surface area, so I'm thinking my graph's going to come down like that. Obviously my scale's not big enough. Just maybe go to 50, and then maybe make that up to 1,000. Okay, see if that's going to do the job. And graph. Okay, so I've gone certainly over there. Okay, so I can just bring that down, maybe make that 10. Right. Right, so I'm looking for this point down the bottom there. I'll have to use my G-calc again. Let's go to minimum, number 3, left-hand side, yes. Go to the right-hand side, let's just type in 10. Okay, enter, and that will find that point for me. So the minimum value is when the radius is equal to 5.42. Okay, so 5.42. So we go and we can sketch that. Part C. Right, so we know this is coming down like that. Remember that it's 5.42. That's 500 and I think 33 by memory. 553.58. 553.58. Okay, so remember, make that 1,000. This is the area, surface area, and this is our radius over here. So we're making it up to maybe 10. So that's my sketch of my function over there, part C. Use technology to find that minimum value. So what value of R makes the areas as small as possible for part C? All I have to do is say R is equal to 5.42 centimetres. And then we go to the next bit. Draw a sketch of the dimension of the can with the possible surface, the smallest possible surface area. Alright, so all I have to do then is find what my H value is. Okay, so my H value I know is equal to 1,000 divided by pi times by 5.42 squared. Alright, so if I go to my calculator to do that, let's quit out of there. So 1,000 divided by, remember to use a bracket, pi times by 5.42 squared, and that should work that out to be 10.84. Okay, so then obviously to draw your particular can here, which is the biggest. Alright, so my can's going to have a radius of 5.42 centimetres. So guys, in terms of the optimal solution is 5.42 by 10.84. So that's really what you have to do to finish that question off. Now, I would like you to have a go at exercise 2B and try and finish those off for me, please. Thank you. See ya.